Known of all civilization scales is undoubtedly the Kardashev scale. Conceived by Soviet scientist Nikolai Kardashev back in the 1960s, it has become the dominant way to judge how advanced humanity might get, or how advanced any potential extraterrestrial civilization might be. It's entirely preoccupied with how much energy a species is able to harness. A Type 1 Kardashev civilization, the lowest rank on the scale, should be able to harness the energy of its home planet. This means humans would need to be efficiently using every type of energy available to us here on Earth, and especially solar energy, which Kardashev himself particularly specified. Of course, there are many other renewable sources of electricity, like tidal power and wind, that don't rely on the sun. Some scientists have even said that Earth and humankind are already a Type 1 civilization, though we could definitely be harnessing more power from the sun with larger solar farms. We can, in theory, however, produce enough power to meet Earth's current needs, especially if we stop relying on fossil fuels and make the transition to green energy. So we really don't have far to go until we truly do become a Kardashev Type 1 civilization. However, Type 2 is where things get a little strange for Kardashev, as we'd need to be able to harness the entire energy output of the sun, rather than just the solar energy that reaches Earth. This is a massive amount of energy, and it would take some very ambitious tech to pull it off, including a Dyson sphere or Dyson shell to encircle our star and absorb all its energy. This could have potentially damaging effects on the rest of the solar system, however, namely that if you block out the sun, we'll all freeze. In this apocalypse of our own making, we'd have to divert energy into heaters to keep us alive. Bafflingly, though, Kardashev then makes a leap of unimaginable proportions to go from controlling one single star to controlling the energy output of an entire galaxy for Type 3. To go from one star to hundreds of billions of stars is unfathomable, and it's this very leap that has led to people wondering about alternatives. It's really not clear if any civilization could ever accomplish such a thing. It is worth noting, though, that Kardashev's scale was designed to indicate civilizations producing enough radio waves that we'd be able to see them from Earth, which is why it has such lofty and stringent requirements. The Zubrin Scale, on the other hand, is a lot looser and more flexible. It was proposed in 1999 by American science writer and aerospace engineer Robert Zubrin, who laid out the idea in his book, Entering Space: Creating a Spacefaring Civilization. Zubrin isn't as concerned with humans being able to spot distant civilizations, just with what's a more realistic trajectory for us. Like Kardashev, Zubrin Scale has 3 types. But while the Zubrin Scale also requires humans to master our home planet, it looks at overall exploitation of resources rather than just energy. On the scale, we'd need to be effective at extracting resources from Earth without damaging the planet, which is something we should be able to do, even if we don't always do it. We also needn't be using all of Earth's resources to hit Zubrin Type 1, however, meaning we don't have to burn up every single fossil fuel, for example. We just need to be adept enough so that humanity's requirements can be easily provided for. The Zubrin Scale also looks at how we distribute food, water, and even building materials, for instance. Altogether then, on the Zubrin Scale, we are actually already a Type 1 civilization, and firmly, rather than only debatably Type 1 as per Kardashev. Even the most basic intelligent civilizations, like the ones early humans built tens of thousands of years ago, would in fact count as a Zubrin Type 1, just at the lower end of this more flexible categorization. So far, there are obvious similarities to the Kardashev scale, but the differences become more pronounced when we enter into Type 2. In Zubrin Scale, Type 2 is based on how we manage the resources of our star system, but there's no requirements to harvest all the solar energy at once, as there is with Kardashev. Instead, Zubrin focuses on the most realistic future trajectory of humans colonizing other worlds. He himself remains a staunch advocate of human Mars missions and the construction of habitable settlements on the Red Planet. Humans have been looking towards Mars and the Moon as future homes for our species for decades. NASA's lunar return is now being closely followed, and all eyes are on the race to Mars, so it looks as if we'll break ground on being a Type 2 Zubrin civilization before the end of the century, or sooner. Again, for Zubrin, we only need to be able to extract enough resources from the solar system to continue our species. And helpfully, the solar system is rich with metals and water ice. Some asteroids are so metal-rich that they're worth trillions of dollars and could be used to construct space habitats, according to some plans, to house larger and larger numbers of people beyond the confines of planet Earth. If we're going to build things like generation ships or orbital space cities, we'll need a lot of building material, and that's where asteroids are extremely useful. And since there's nobody living on or near these asteroids, not to mention the impossibility of asteroids hosting life, we don't have to worry about harming any ecosystems by mining asteroids. Plus, if these processes are automated, there's no risk to human lives through dangerous outer space mining. In Type 2, we'd eventually expand to build habitats beyond Earth and Mars, potentially going as near to the Sun as Venus if we decided to live in its clouds, and in so doing, we'll have become a society that utilizes its entire solar system to thrive. Zubrin's Type 3 is once again similar to Kardashev's Type 3 in that it's about mastering the galaxy. But we don't necessarily need to control every single planet or star this time around. We just need to have expanded beyond our home system. Generation ships are the first and simplest way to do this, as the destination is less important than the act of journeying through the galaxy. But we could also eventually go to other star systems and start living on the exoplanets within them. It's likely that, minus the extreme distance, it's no harder to settle on worlds in other star systems as it would be on nearby bodies like Mars and Titan. Although, of course, anyone setting up base on an exoworld would have to be even more independent. To make any of this possible, there are some pieces of technology that we'd definitely need to develop first. For a start, we'd need to find a way to travel much faster, and potentially faster than the speed of light, likely using a warp drive if we can figure out a way to power one. But perhaps more important than traveling faster than light is sending communications faster than light. Communications like radio signals already do travel at light speed, but at the distances we're talking for Zubrin Type 3, even that is way too slow. If there's a human colony in a star system 1,000 light-years away from Earth, it would still take 1,000 years for a message to reach us, and another 1,000 years to send one back. Unless then we wanted to say goodbye to those space travelers forever and simply hope for the best for their futures, we need faster-than-light communications. This is something also implied in the Kardashev scale, because it's no use having a pan-galactic civilization if none of the different star systems can talk to each other or share resources and knowledge. Poor communications could also lead to the starting of wars, and that's not what we want either. Humans have been waging war against each other for thousands of years, but it would definitely be best if we could leave all that behind when we reach Zubrin Level 3. To avoid warfare, all of these outposts, from Alpha Centauri and beyond, would need their political independence and priority for the resources in their home systems, as well as the choice of what to keep and what to trade between other systems. In effect, this particular scale of our advancement calls for a strong, galaxy-spanning human empire, but not one that's so massive it can't be controlled and inevitably collapses, which is what's generally happened to empires on Earth throughout history. With the right research, knowledge, technology, and respect for one another, humans could rise all the way to a Zubrin Type 3, a cohesive galactic force, in just a few thousand years. And that's how far along the Zubrin scale humans could get. But what's your verdict? Do you think we'll make it?